welcome to the lecture 12 of Safety and Risk Analytics. Today we will be discussing on missing data handling. This is coming under module 3, Safety Data Quality Assessment and Pre-Processing. The concept that we will discuss today is missing data, problem faced due to missing data, types of missing data handling with example. While preparing the slides, we have taken a good amount of conceptual as well as example based from Chima Jr. 2014, a review of missing data handling methods in educational research. In addition, we have taken information from some other sources that we have given at the end. Now, what is missing data? You just think of a data set like this, which you observe or which you have collected or which you have taken from some secondary sources, and in a data set which is a two-dimensional array, usually the columns represent the variables or attributes and row represents the cases or observations or individuals or items. And the first column usually talks about observation number. Second columns to the last column, these are basically related to different variables and attributes. In this particular example, we have considered the first column as incident path. We have discussed what is incident path earlier. Suppose there are 10 different incident paths that are documented in an Excel array, and then the second column is talking about incident causing mechanisms, whether it is process related, equipment related, human related or environment related. So primary that issue is process related, then it is process or equipment in human or environment. When you talk about hazard, we can classify process related hazard, equipment related hazard, human related hazard and environment related hazard. So based on the incident initiating event, suppose the incident causing mechanisms collectively process related, equipment related, human related or environment related, that is given in the second column. In the third column, risk control system status is given. That PRCS means preventive risk control system and MRCS is mitigative risk control system. Now, what are the different class of risk control system that are responsible for this incident path to happen? In the first case, it is inspection and maintenance. Second case also inspection and maintenance. Third one is competency. Fourth one is operating procedure, like this. So in this manner, for MRCS, that emergency arrangement operating procedure. Apart from these, there are two other columns, P and C. P stands for probability that the path will occur and C stands for the consequence or if the path occurred or that this particular accident or incident has occurred. And if you see the data, then you are finding out there are many categories, like for ICM, PRCS and MRCS, different categories of information are there, and for P and C some numerical values are given. Probability and consequence in terms of some numbers, like 2 means from some qualitative to some kind of numeric scoring has been made here. It is not 0 to 1, but it is within 10 point scale. Apart from this, you see that there are some question marks. These question marks basically are the missing data. You may find out the instead of question mark the blanks will be there. So if you put on the blanks question marks, basically usually when we talk about data with missing values, we usually we understand in this manner. That means basically that there will be input data, that attribute or variable values. Wherever variable values are not there, either it will be blank or it will be put under some question mark will be given. So now this is basically real observations. Now apart from that means, apart from this, then if we say missing data, what more we want to know, that the missing data, as I told, it is basically the cells with no data or with some data which are not actually qualified for data, and or some question marks. Usually all the missing cells can be replaced by a question mark. And then second one is, you can generate missing pattern from the observed data. So the missing pattern is given in the next table. Here we have used 1 and 0. Wherever the values are available, put 1. Wherever the values are missing, put 0. So this will tell you that which are the attributes are having complete data as per the given data set, which are not, and where the missing data is more. For ICM, there is no 0, so it is completely given. PRCS, there are 2 zeros, so 2 missing values. Similarly, MRCS, 1 missing values. Like P, 2 missing values, and C, 3 missing values are there. So if there are missing values, this lead to loss of efficiency, then complication in handling and analyzing the data, bias resulting from differences between missing data and complete data set. Why such deficiencies are occurring here? The primary reason is because it may so happen that the missing data generates maybe because of certain other reasons which are not related or which are not equivalent to the data what we have already observed. So that means what we are basically trying to tell more precisely, that missing data generation and observed data generation, that may be from the two different process. Okay, so that's why it lead to lot of complications, because if there are more missing data, as these may be coming from a different process of data generation, which are different from the complete data generation or what observed data generation process. So then there can be theoretical assumptions related problems. Okay, so I hope that now you understand that what is missing data. In the previous lectures, we already given you how to collect safety data, what are the different sources of safety data, different types of safety data. Now we are basically focusing on a small data set and trying to understand different concepts, as missing data is an important concept, and as well as it has lot of implications in data analysis, so we have to understand this. Apart from this, what I want to tell you here, that suppose some of the cases, suppose 0 value is appearing, so this 0 value is not missing data, this is the real observed value. So we should not get confused that 0 is a missing data. 0 value in the original table, suppose if this is 0 instead of 5, then also in the missing pattern it will be 1. Because the 0 is the value which was observed, provided the variable what you have considered or attribute what you have considered can assume 0 values. If it is not, then you can think of that it might be a missing one, someone by mistake put 0. Okay. So I hope that you got the idea of missing data. Now, what are the different regions? So from different sources, we have jotted down the regions. First reason is poor trial management, lack of follow-up, followed by fail to fill in questionnaire. These are the ways, because the way you are collecting data, and if it is a real observation data, so probably you fill up the Excel sheet where you fail to fill up certain data, or when you are talking about giving some questionnaire to people to respond, some of the questions might not have been answered. So many things are there. So I just listed down that what are the several reasons. There could be more reasons. Leave study for no apparent reason, inconsistent with other recorded data, thus deleted, data not entered due to misunderstanding, certain data may not be considered important, so then no register history or changes of the data, non-coverage of missing data, then total non-response, then item non-response. So something it is given here, but need not be that this is the complete set of reasons. You have to know that what are the different other reasons. So if you have expertise about the data collection process, if you collect primary data where actually you are directly collecting from the source, so you know what are the reasons for missing data. If you collect from secondary source, then might be you have to understand, you have to talk to the people there, that what are the sources, because the sources of missing data is important, and if we understand what are the reasons for missing data, then you can rectify all those that lacunas, and you can get better data, non-missing data. So after this missing data, that definition, now we want to tell you that why the missing data, but what are the mechanism of missing data generation. As I told you that missing data generation, it's a process. There are certain processes which basically provides the missing data. So these types of missing data mechanisms, a very important one, and this one we have taken from Cheema Jr. As I told you that this Cheema Jr. That paper, that missing data handling paper, is the primary source of this lecture. So missing data can be of three types. One is MCAR, missing completely at random, missing completely at random, and second one is missing at random, and third one is not missing at random. So we will define what is missing completely at random, missing at random, and not missing at random in the next slide. So here I am just giving you an idea. Missing completely at random means, suppose you take up any attributes and a particular cell of that attribute, suppose where there is a question mark or blank. So that value may not, the occurrence of that blank or the question marks or missing data, missing value there, or may not be related to the attribute, or may not be related to the other attributes in the data set. Neither the cases nor the attributes in the data set. It is something happen randomly, then this is missing completely at random. Then if your data is missing completely at random, then you have a interesting way of looking into it. If it is yes, so you have one path. If it is no, you have another path. If yes, that it is completely random, then the usual path is there adequate power of test of hypothesis? So now question is, you are basically talking about that whether you delete that particular case or not, and accordingly your data set, complete data set will be generated. So I will come back to this slide again. Let me go to the next slide. here I think I must define first that the things like what is your three classes of missing data, that missing data mechanism point of view. Now let us understand that if we are talking about data denoted by y, say then it can be partitioned into y0 and ym. Y0 means observed data on y and ym is missing data on y. And you have seen that we have basically shown you the missingness pattern where 1 and 0 we put. So that means we created an indicator variable r and we put r equal to 1 if y is observed or 0 otherwise. Now let denote probability r given y0 ym or PR r given y0 ym is the probability that a set of missing values given the observed and missing observation. So if you consider the data table where I have shown you that in the column 2 there is no missing data, but column 3 there are 3 missing values, column 4 some missing values are there. So any one column if we consider suppose y, then there will be two sets, one the observed data and another is the missing data. Now if we consider that the probability that r equal to 1 and r equal to 0 given y, or which is basically partitioned into y0 and ym, that actually gives you an idea for the definition of MCAR, missing completely at random, missing at random and not missing at random. Okay, so with this we want to define what we are doing here. Now we want to define first missing completely at random. That means if you have a missing value here, now what is the probability of this missing value? Is the probability of missing value here depends on observed as well as unobserved data, observed as well as missing data. If it doesn't, that means we are saying that this condition r given y0 ym is PR, that means it doesn't govern by the y observed or missing data. Then it is missing completely at random. The source is Van Buren and Guthias Oudasum. So this is this source, we have taken this information. Okay. If your your probability r given y0 ym, that means this one, suppose this is this missing value we are basically talking about. So in that case what will happen if it is depend on y0 already observed data. Now here the observed data, whether you consider a particular attribute or the entire data set. So usually when we say y0 and ym, we talk from the entire data set point of view, what are the observed and what are the not observed case. So depending on your domain expertise, you can consider one attribute at a time and do something, but you can consider the also the other attributes, because there may be correlations or covariate relationship among the attributes. So you have to understand that part. So that is not very simply to say mathematically that you do like this, but more or less when you have this kind of things, when your data or missing value, that one doesn't depend on the missing data. Here r given y0, so only observed data. So that means this, if this is missing, it has some link with the observed data in this data matrix, and it will give then what will happen if it is not completely random, because there is some relation. Okay, so that you can do. So that means when it is missing completely at random, at that time, as I said, as it is completely random, you have a lot of flexibility in putting certain values to that. We will discuss. But when it is missing at random, so that means you have to consider some other relations. And when it is not at random, if it is not at random, not missing at random, that means you don't know whether it is related to the other very observed or unobserved, or it's a complex relationship. Now, if you want to understand some of the examples, suppose the first case when missing completely at random, for example, we can say computer malfunction erase part of the dataset. This kind of situation it is because computer malfunction is a random phenomena, so erase of dataset will be a random one. If we say the second one, that missing at random, here one example is a survey where participants older than certain age refuse to answer a particular survey question, and age is measured in the study. That means one of the attribute is age, and second maybe we are asking that okay, what is your safety performance? This is the another one, but certain age group they say no, we don't want to participate. So that means because of certain age group refusal, the missing data has happened. Third one is some incident path may be critical from societal perception point of view, and concerned organization does not want to disclose certain information. So that situation, but it is a debatable one. So we basically give it to all of you to understand, to discuss on it, and give some comments on the forum, or otherwise you generate your cases where you can find out these three different kind of missingness. That means when you talk about missingness, we basically talk about missing completely at random, missing at random, and non-missing at random. Okay, so non-missing at random means basically not missing at random means there are certain reasons, and those to be explored. Now with this I want to go back to previous slide again, and I want to say that now you understand that what is MCAR, what is MAR, and what is NMAR. Here I want to tell you that not only that what the type of missingness, but at the same time we want to give you some idea that how to handle the missingness. The handling of the missing data here is, if suppose data missing completely at random, it is yes. Then if you delete the data as it is at random, it will not have any impact on the other observed values, and if the data set is a large data set, deleting certain observations of certain cases will not be problematic, and if you do certain kind of model to develop the insights, and then after that if you find that the adequate power of what hypothesis you are trying to test based on the model, and adequate power of for test of hypothesis it is well established, then what will happen, in that case you can go for listwise deletion, means wherever you are finding out the missing values, then those cases, those observation, entire observation you can delete. If you find that no, there is it cannot be deleted because of adequate power of test is not justified, So in that case, you have to impute missing data, means that cell you have to fill with certain data. So that means if it is missing completely at random, you have to check whether the adequate power of test of hypothesis is there or not. Power of test is a concept which basically that there are two type of errors, type 1 and type 2 error. Type 1 means basically rejecting a correct hypothesis, and type 2 is basically rejecting a accepting a false hypothesis. So this kind of and then beta, that power of test is basically 1 minus beta, that is means how good your hypothesis is to reject the false hypothesis. So those things we will not discuss here, but at the same time you have to have some way of understanding this, and then you can go for this. But you may ask me that, okay, at the beginning, how do I know whether hypothesis, that power of hypothesis is there or not? So obviously that literature review, your previous knowledge, number of attributes you consider, number of the sample size, and all those things will help you to understand, or approximately you can think of the no, it is if deletion is possible, or otherwise you delete and then go for the test, and after that if you find that the deletion doesn't affect the power of the test, that's fantastic. If it is not missing completely at random, so then there are case of missing at random. If missing at random is the sample size representative of the population after list-wise deletion, means if your sample size doesn't have any problem, go for list-wise deletion. Okay, and if you do list-wise deletion and after that again you have to do the same thing, that the power of test is there or not. So if yes, fine. So you don't require to do anything. Fantastic. If it is no, then obviously you have to impute data. If missingness mechanism is neither completely at random or not at random, then what will happen? It is called not missing at random, and you cannot do this kind of list. The deletion process or imputation process may not be working well. So what is required? Your missing data mechanism must be modeled as part of the estimation process. Okay, so suppose you are doing regression with missing data. So in the estimation, the missing data will be regression parameter estimation, missing data has to be considered. So these are the few important things related to missing data, and I discussed with you that what are the different types of missing data, and how and when you go for what kind of and how to handle the missing data. That way I discussed a part of it, but I have not discussed the much details of handling. Here I just listed down some of the methods to encounter missing data. First is case deletion method. That means you delete the cases where data is not available. Now how do you delete? So there are two types of deletion. One is your deletion is basically list-wise deletion. Only analyze cases with available data on each variable. And pairwise deletion is analysis with all cases in which variables of interest are present. So if you consider the data set, these columns are basically attributes. Suppose this is my missing data. Now in the first case, basically suppose you are interested in only in this variable. So it is better you delete this one only and do the analysis. Suppose you are having this another attributes you want to consider, and here also one data is missing. So what is required? If you want to take these two variables, then this case as well as this case, this would be completely deleted. So that means pairwise deletion. If you use the entire data set and these two cells are having missing data, then complete that cases will be deleted. Rest of the cases will be considered because they have the complete data set. But this kind of deletion method is possible only when you have huge data. Okay. So, and second thing is that if you know that your missingness mechanism is known and it is either at random or completely at random, then the deletion method will work. If it is if the number is not large, so you have to impute data. So imputation based method you have to consider. What are the different kinds of imputation method? Mean imputation, regression imputation, maximum likelihood, expectation maximization algorithm, EM imputation, multiple imputation, hot deck imputation, dummy variable adjustment, zero imputation, single random imputation. So these are the different kinds of imputation techniques are available. We will discuss a few of them, and you may go through the paper written by Chima, where you will find out more details of this type of problem. Now let me discuss about the case. First one is list-wise deletion. Now in the list-wise deletion, see this one, that blue color line. Here what happened, we found in this data set almost this entire set that observation is having missing, so you delete it. It is difficult to impute in this case. Now if you are basically, suppose in the pairwise deletion, suppose another example, I want to compute the risk of individual incident paths. So risk in a two parameter model, it consider P cross C. So that means if I want to compute risk, I have to have P and C data for each of the incident path. Then if you want a complete data set, so then here for C data is missing. In the for sixth incident path, P data missing. For the 8th one, again C missing, and for the 9th one, both P and C missing. So if you want complete data set, then the pairwise deletion means these 4 data set observations need to be deleted. Out of 10, you are deleting 4, you are having only 10 data sets. Okay. So this is the way pairwise deletion is basically considered, because you want to get maybe the average risk, then that 6 risk values you compute and make the average of the 6 or the total risk value is compute. Okay, this is known as your list-wise or pairwise deletion. Again, I told you, if data is not missing at random, if not missing at random, so you have to consider the missing data during the estimation process. When it is MCAR or MAR, this deletion method or imputation method will work. Now imputation method, we said that mean imputation. Again, I will consider the P. So here no data and here no data, like these two. So let you consider P only. For the other 8 cases, whatever the probability values considered, take the mean of those and then impute here. This is called mean imputation. Mean imputation basically very much work when this one is completely at random, missing completely at random. That is the better one. Just mean imputation will be. Now sometimes what happen, we can do zero imputation also. For example, here we are putting 0. The reason may be we see that the probability of occurrence is high, then usually that when some incident having high probability of occurrence, its consequence usually negligible. So that sense you can put 0. If this kind of just logical justification you have, put this. So that means putting the whether 0 or non-zero, again it all depends on your understanding about the particular observations in terms of data generation. Okay. So let us go for the next slide. Then there are some other methods where it is not easy to explain here with example, because you require to know some of the techniques like regression imputation. So what will happen if in case of regression imputation, you suppose you consider, let the three variable y, y1, suppose x1 and x2, y, x and x2. So you have complete data set for all three and some missing data, let for y. Then what you do, you fit a regression with this as a function of x1 and x2, and wherever y's missing data is there, after this regression model is regression equation is known, then put the values of x1 and x2, and whatever this that expected value of y given x1 and x2 you got, that value will be replaced. So this is very popular method, but primarily in the numeric data side it is applicable. Another one, as I told you, that expectation maximize EM algorithm you can use. What actually we do, we assign in the missing values, you assign some initial values, and then use as the algorithm like expectation, maximize the expectation with the initial values, and then actually put certain values, maximize, then again recalculate the values, put that one, again you maximize, and in this the process, iterative process continues. And when you find out that no further improvement is possible from that expectation maximization point of view, you stop there. That is the convergence point. So this is another, and multiple imputation means it is basically some kind of simulation based imputation. You create several complete data set, and then if you have for the same data set with different missing values, you have different complete data set. For the missing values, you have multiple observation for each of the missing values. From there you can capture the natural variability of the missing values, and the lower the standard error of the missing values, that is the better one. So it's another very good technique, but these are all time consuming and laborious one. Then another method is known as basically hot check imputation. This method involves imputing missing data on a variable for a given case by matching that case with other cases in the data set on several other key variables. Means, suppose this is missing. Now you want to impute data here. What you do, you take other variables into consideration where some logical connection is there, and from the other values that logical connectivity with the other variables, you can put a certain value. For example, here replace by EA, this one can be replaced by EA by mapping MRCS. We mapped with MRCS, this is MRCF, and then actually for ICM equipment, because in ICM, incident causing equipment related cases we considered first. Then we found out that for your MRCS, the equipment related cases, that here emergency arrangement, here also emergency arrangement, here it is operating procedure. So out of 3, 2 cases favor for emergency arrangement. So, and also maybe if you can consider some other like some other attributes here, that also better. But here we have one possible imputation is EA, that is called hot deck imputation. So what is hot deck imputation? For a particular missing value, you are finding of an attribute, for a particular missing value of an attribute or missing values for an attribute, you are finding out some kind of logical relation of that variable with other attributes or variables in the data set, and then you are finding out the best possible one. So that is basically known as hot deck. Okay. So I am coming to almost the end of this lecture. There are few more discussion point, and dummy variable adjustment is another one. What you basically do, wherever you have missing data, so for that variable create a dummy variable. For example, we have created dummy variable here for PRCS and MRCS. We are writing dummy PRCS and dummy MRCS. Here nothing but wherever data is there, put 1, wherever values are missing, you put 0, and you can use this dummy MRCS, dummy PRCS for subsequent analysis. This is known as basically dummy variable adjustment. So when you have dummy variable, you keep the original variable as well as dummy variable in the analysis. So then that will give you more insight. Single random imputation is a compromise between regression and multiple imputation. In regression imputation, you have seen that a particular variable is regressed on the other variable, and then the regression variable missing values are found from the other variables using the regression equation. In multiple imputation, what you have seen that it is some kind of simulation based method where multiple data sets are created, and single random imputation actually taking the advantage of the both and also at the same time losing certain advantages. So it's a compromise between the two. Regression of what way it is done? Regression of the variable with missing values on other variables and randomly draw the predicted values from the residual distribution. So first you do regression with other variables, then you randomly draw, means create several your databases, so that both the advantage of regression imputation and multiple imputation you will be able to enjoy. So what you have learned today? You have learned very important part of the data analytics course, what is called missing data handling. Missing data will be there, and if you are dealing with a large amount of data, suppose 1 million data observations you have, or in terms of thousands, in terms of millions, so you will find out that there will be missing data. And in that case, what will happen, if data is very large, then maybe and maybe you can if you find that MCR or MAR conditions are satisfied, then deletion is better. But if it is not that, then imputation has to be done. Sometimes what happens, your data is not small but not big also. In that kind of situation, that imputing missing data is a very important work also. But whatever may be the issue, if data is not missing at random, then the estimation process should take care of the missing data simultaneously. So I hope that you got some idea about missing data handling, starting from your definition of missing data to your missingness mechanism to different methods of handling missing data like deletion method and imputation method. So these are the references. As I told you that this is the reference which basically we consider very much, and then also this reference is also important. Other references are also important, but mostly the first and second one we have considered in preparing today's slide, and I am extremely thankful to you for your kind and patient sharing. Okay, thank you all.